Hi. In this problem, we are going to look at a tournament question. We have a round robin tournament with n players, P1 to Pn, and each player plays one game with each of the other players. So basically, one person will play n minus one games, right, with all the remaining n minus one players. And there are no draws in this tournament. And let WR and LR be the number of games won or lost by player PR. So PR could have won WR games and he has lost LR games. And obviously WR plus LR must be equal to n minus 1, right? Because total number of games for PR is n minus 1. We have to prove that summation of R goes from 1 to n WR square is equal to the summation of R goes from 1 to n LR square. Okay, so let's think about this problem, how we are going to prove this. So I will introduce another strategy for you, which sometimes works, which is basically the strategy of working backwards. So work backwards from the conclusion, and maybe if you can come to some stage where you know something is obviously true, then you can retrace your steps and reverse all your steps and basically say that that is my proof, right? So that is a very common idea in many types of problems. So we will employ that strategy here. We will say, let's assume this is true, right? Let's assume this summation is true. So we'll write summation of R is equal to 1 n WR square is equal to summation of R is equal to 1 to n LR square, which implies that the summation R is equal to 1 to n WR square minus LR square is equal to 0, right? Okay, so let's see what we can get out of this. So we'll say R is equal to 1 to n. We'll factorize it and write it as WR minus LR and WR plus LR equal to 0. Now we know that the total number of games played by the player PR or any player for that matter is n minus 1. So WR plus LR must be equal to n minus 1. So we can take this term out of the bracket and we can write it as n minus 1 summation R goes from 1 to n WR minus LR equal to 0. Now what does this mean? Obviously n minus 1 is not equal to 0. So therefore we have summation R goes from 1 to n WR minus LR is equal to 0, which can be rewritten as R goes from 1 to n WR is equal to summation of R goes from 1 to n LR, right? So this is what we are coming to after assuming the first step, right? We are assuming what we need to prove, and finally we are coming to this step. Now let's think of this. So what does this mean? This means that the total number of victories for all the players. So what is this summation? This is W1 plus W2 till Wn. So total number of games won by all the players is being added, and we are saying that it is equal to the L1 plus L2 till Ln. Right? So the number of victories is equal to the number of losses. But that should be obvious, right? That is obvious because for each person, if I win 2 games, then some other player has won the remaining games, right? So some other player has lost those 2 games. So this is an obvious statement that the total number of games that are won is equal to the total number of games that are lost by all the players, because there is a one-to-one correspondence between a win and a loss. A win for one player is equal to a loss for another player, right? And the number cannot ever change. So because we have come to an obvious fact here, we know that the claim that we said in the beginning must be true, right? So the strategy for formally proving it would be to start from this step. You should start by writing this and claiming that this is obvious, or you can even show a one-to-one correspondence between wins and losses. And then after that, you just rework all the steps. So go backward, do all the steps backward, and finally you will come to this conclusion, right? So you're going to reverse all your steps and you will get to the conclusion that you need. So I hope you have learned an interesting strategy here. This is useful in many types of problems. This is a common problem solving strategy. So please take advantage of this in future problems. And if you like the content, please subscribe to the channel, like the video, and share it with your friends. Hopefully you will find it useful and your friends might as well. I'll see you in the next video.